You got into a fight. Let's not talk about the reason. What should you do? Die? That's all. Why? Wrong. You should remember your old physics degree. But if you don't have one, it's not a problem. Isaac Newton is always on your side. And let me tell you a secret. Newton hits hard, that's for sure. Act 1. Force. I hope all of you heard about this formula. Force equals mass times acceleration. Simple, right? But you sure can't imagine what kind of power it gives you. Most people think that to win a fight, you only need big muscles and to hit hard. Wrong again. If you hit just with your arm, mass is just the mass of your arm, which is very little, and therefore weak. Actually, you have two options. You're a giant and weigh 80 kilograms or more, then don't just throw a punch. Instead, act with your whole body. You need to fall forward onto the enemy, and then you'll be attacking with the mass of 80 kilograms, which is not that little anymore. But what if you're a tooth fairy? Then imagine your hand as a whip. Mass is small, speed is awfully high. Just relax the muscles and let the speed rule. Your acceleration will be very high, and you'll be no worse than a giant. Act 2. Pressure. Now that your horse is great, let's talk about pressure. Pressure equals force divided by area. If you slap someone with an open palm,
On this train.
it'll make some noise. It'll hurt a bit, but won't cause real damage. More like a pillow fight, not a slap. What if we make the area less? Instead of a flat hand, you are now striking like Kung Fu Master, just with the side of your hand or a bent elbow. Suddenly, you've reduced area by 90%. The mass here is brutal. Shrinking the area makes the pressure multiply. Now you ain't just hitting anymore. You are focusing all your energy in one place. Act 3. Center of mass. Alright, you know how to hit. But what if your opponent is a 100 kilogram tank who couldn't care less about your punches? You don't fight his muscles. You fight his center of mass. Every object in the universe has a center of mass, the balance point where all its weight is concentrated. You can see it as a glowing dot. Think of human as a big Jenga tower. As long as that glowing dot stands directly above their feet, the tower is stable because it is pushed down by gravity. But what if a dot is moved outside its position? Gravity stops being their friend and becomes their enemy, pulling them off to the ground. So how to use this? First, lower your own center of mass. Drop your hips, bend your knees, widen your stance. You were just raised to a heavy stable pyramid. Wish good luck to your opponent. Second, move their center of mass. If someone rushes at you, don't push them back. Instead, pull them in the direction they are already moving, or step outside and trip their foot. They have forward momentum, and their base is basically removed. Gravity is now on your side. Act 4. Impulse. But wait, physics isn't just about offense. What happens when you're about to get hit? Welcome to the defense. In physics, impulse is the change in momentum, and it equals force multiplied by time. If we rearrange that, we get force equals impulse over time. This means that if you have to absorb some amount of force, you can change it by changing the time. Imagine dropping an egg on a concrete floor. It smashes instantly because the input time is almost zero, making the force approach infinity. Now drop the same egg onto a pillow. It survives. Why? The pillow deforms and increases the time, making force almost nothing. In a fight, you need to be a pillow. If a punch is coming at your face and you can dodge it, parry it. No. Roll with your punch. Roll with the punch. Move your head backwards in the same direction as the fist. That way, you extend time and make the force last. Sounds tiny, doesn't it? But if we double the time, which is itself real small, we cut the force in half. And if you are absorbing the punch with your arms, don't think of them as walls, but as a spring. So next time you're in fight, don't flex your muscles, flex your brain. Outro. The fight.
3, 2, 1.